All right, so the first one. Combine like terms. 8x to the fifth minus 9x to the fifth is what? Thanks, you guys.
Oh,
It's subtraction, right?
It is.
All right. Is there an x to the fourth in here anywhere?
No.
No. Okay. So x cubed, I got a 6x cubed minus a negative 1x cubed. That's adding 1, right? Minus a negative is addition, right? X squared, negative 2x squared minus a negative 13x squared is a negative 2x squared plus 13, which is plus 11. Are we catching those minus and negative things? Hopefully we are. 10x, and there's no other x's, right? And there's no constants, so this minus 4, nothing minus 4 is negative 4. Okay? That's easy stuff, right?
Yeah.
Just that minus and negative stuff, sometimes we mess up on. Okay, for this one, a multiplication. I'm going to multiply 5x squared times both of those to start. So 5x squared times negative 2x is a negative 10x cubed, right? You add the exponents. 5x squared times 3 is 15x squared. Negative 4x times both of those. Negative 4x times negative 2x is a positive 8x squared. I like to line up the like terms when I do these. But you don't have to do that. You can just write them all out in a long line if you want. Negative 4x times positive 3 is negative 12x. Then I'm going to go 6 times both of these. 6 times negative 2x is another negative 12x. And 6 times 3 is 18. All right, so as you can see, I've got a couple like terms there that I have to combine now. So our answer is negative 10x cubed. 15x squared plus 8x squared is 23x squared. Negative 12x and a negative 12x is negative 24x plus 18. Just for quick review, what's the degree of this polynomial? 3. What's that special name? Cubic. What's the leading coefficient? Negative 10. Okay, just some things we went over Monday, just to review. Okay, so I gave you the answers to the homework. All right, any of these that you would like me to go over with you? 4 and 6 is addition. 8, 10, and 12 is subtraction. Any of those you'd like me to go over? Not sure about? Nolan? 16? All right, so this is multiplication. So I'm going to go negative x times all 3. I'll do that first. So negative x times 2x squared is negative 2x cubed. And negative x times 5x is negative 5x squared. And then negative x times 8 is negative 8x. And then negative 3 times 2x squared is a negative 6x squared. And negative 3 times 5x is negative 15x. And negative 3 times 8 is negative 24. All right, so our final answer then, combining like terms, we got our negative 2x cubed, negative 5 and negative 6, negative 11, negative 8, negative 15 is negative 23, and then the minus 24. Did I make a mistake when I did it? Is that what I had? Because I was doing it in a hurry this morning, and I might have made a mistake. I thought I caught the ones I made a mistake on. All right, how about 18, 20, we okay? 22, 24, any problems with those? Just do two first, get an answer, then multiply by the third one, right? And then the last three were the ones that we had special products. We had special rules that we went over yesterday to do. All right. The hardest one's probably the 36. Again, if you don't remember the rule, I'll go through the rule. But if you don't remember it, just write 4n minus 3 times 4n minus 3. Get that answer. And then multiply the answer by 4n minus 3. Okay? If you don't remember the rule. Okay, the rule is take the first term and cube it. So you cube the 4 and the n. So that's 4 times 4 times 4. And n times n times n. So that's 64 n cubed. All right? There's going to be 4 terms. All right? When it's got a cube, there's actually one more term than what it is. That's going to kind of tie into what we're doing today. We're going to learn a different way today to do something like this. All right? Which you might like better, you might not. All right. Anyway, the next thing we're supposed to do is square the a part. Remember, we called this the a part when they did it, and this the b part. All right. So the second term is 3a squared b. All right. So when I square the a, 4n times 4n, I get 16n squared times the b times negative 3 is negative 48n squared, then times that 3. And negative 48 times 3 is negative 144. And then that a is squared and the b. Then the next term is 3ab squared. So you're supposed to square the b, so negative 3 squared is 9, times the a, 4n, is 36n, and then times 3. And 36 times 3 is 108. So it's 108, what was it, n? Well, I wasn't supposed to do a squared b, I was supposed to put n squared, wasn't I? My bad. I'm looking at the a's and the b's, but it's n on this problem, right? And that's an n. Okay, sorry about that. And then the last part is cube the b. Negative 3 times negative 3 times negative 3 is negative 27. So that's the shortcut rule that we talked about yesterday. Special products, we call them. All right. So again, it was the way they showed it to us was like this. They said a minus b cubed was a cubed, and then minus 3a squared b, and then I think it's plus, usually, yeah, plus 3ab squared, and then minus b cubed, I think is what the rule was, if I remember right. Did you put away this? You have, here it is, day one. So confusing. Yeah, that's the shortcut. Yeah, so it's a cubed minus 3a squared b plus 3ab squared minus b. Yeah, I did it right. All right, any other questions on the homework? All right, like I said, we're going to learn a different way today to do number 36. And you might like it, you might not, okay? Let's see how we do, all right? So we're going to talk about Pascal's triangle today. This helps us figure out how to do these, what we call binomial expansions. The binomial has how many terms? Two. So it only works for these binomial expansions. All right. So we got a plus b to the nth power. It says for whole number values of n. So again, it's going to be an exponent. You know, if we have a first or second power, we're not going to waste time doing the binomial expansion, the Pascal's triangle. But when it's cubed, or 4 or 5 or 6, it's a lot quicker if you do Pascal's triangle like we're learning today. It says when you raise the coefficients of the variables in the expansion of a plus b to the nth power, you will see a special pattern called Pascal's triangle. Pascal's triangle is named after French mathematician Blaise Pascal back in the 1600s. Okay. All right. So it says in Pascal's triangle, the first and last numbers in each row are 1. So if you look at each row of the triangle, it starts and ends with a 1. Okay? Every number other than 1 is the sum of the closest two numbers in the row directly above it. Okay? So, well, they call this top one row 0, and they call this 1, 1 row 1. And then they got 1, they always start with 1. And then what is 1 plus 1 up above this? 2. So that's why they got the 2. And then they always end with the 1. Okay? Start with a 1, then they do 1 plus 2, which is 3. And 2 plus 1 is 3. And then they end with a 1. So that's how they're getting these numbers. Start with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So once you get the idea how to do it, it's real easy to make it. Any questions on how they get those numbers? Okay, so you always start with these 3 1s to get going. And then you start row 2, we call this. So that's row 0. And then row 1, 2, 3, 4. Well, when mathematicians were doing these problems the long way, okay, they were noticing they were getting these numbers for coefficients of the terms. So Pascal figured out this little triangle that matched those numbers is all that's happening there. Okay, so if we did a plus b the long way, it would be 1a to the 5th plus 5a to the 4th b plus 10a cubed b squared and so on. Okay, it follows these numbers here. Okay, any questions on how to make Pascal's triangle? Okay, so you always start again with the 3 1s like that, and then just start the next row, which we call row 2. So we don't really use it for these 2 rows, 0 and 1. We can start using it here, but that's the second row, and it's the second number. You can figure out what row it is. Okay, and row 2 goes with exponent 2. Row 3 goes with exponent of 3, and so on. Okay? So this binomial expansion says there are n plus 1 terms, okay? N being my exponent. So if I have it to the 5th power, when I'm done, how many terms will it have, your polynomial? N plus 1. If n is 5, 6. Okay, there's always going to be one more term than the exponent. Okay? Okay, the exponent of a is n in the first one, and then the exponents decrease by 1, and then the exponent of b is 0 in the first term, and then the exponent increases by 1, and the sum of the exponents in any term is whatever the power is, the original one. Okay? Again, you don't have to remember all that, because I'm going to show you how to do it. All right? But that's just what's going on. Don't zone out on me, will you? All right, again, here's Pascal's all the way up to 16 rows. Again, you're not going to have to go that high. You'll probably only ever get to maybe the 6th row for a problem. Okay? That might be the highest you'll ever have to worry about. But just so you can make it, all right? That'll long as you can develop or make the Pascal's triangle, you can do this real easy. All right, so let's look at some examples. All right, so since it's to the fourth power, I got to go to row 4 on Pascal's triangle. Okay, so I'm going to make row 4 real quick. Row 0, row 1, row 2. 1 plus 2 is 3, 2 plus 1 is 3. Row 3, row 4 is going to be this one. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and with a 1. So that's the 5 numbers that go with this one. Okay? You with me on how I made that real quick? That's simple, right? Yeah. Okay. So here's what we do. All right? I'm going to go 1 and make 2 sets of parentheses. Plus 4, make 2 sets of parentheses. Plus 6, and make 2 sets. It's always plus also. We might get pluses and minuses as we go, but I always do plus to start. And then I got to add one more. I run out of room, but I want to make it big enough so you can see. So down here, I'm going to have a plus 1 again. Okay? So, this first parenthesis, you put the first term in. Every one of them. Okay? So what do you think goes in the second parenthesis? The second parenthesis. Okay? Now, since it's a plus 2, I'm just putting a 2. But if it was minus 2, I'd put negative 2 in the parentheses. You with me on that?
Yes.
Okay. So, okay. So far, so good? Yep. All right. Since this is a 4, all right, this first parenthesis has a 4 exponent. And then as I go to the next parenthesis, first parenthesis, I go down by 1s. All the way to 0. Okay? So whatever the original exponent is the first parentheses exponent. And then you just go down in order by 1s, all the way to 0. Now what do you think the second parenthesis starts at?
4.
No.
0.
0. And what do we do with that?
Go up.
Go up by 1, yes. Okay? So this second one always starts at 0. And then you go up by 1s. Now you just find the answer to each one of those 6 problems. And that's your answer. Okay? So, here's what I do also. Wherever we all know that anything to the 0 power equals 1. Anything to the first power is itself, but anything to the 0 power is 1. So if I multiply by 1, am I changing it at all? No, I'm not changing it at all. So here's what I do with the zeros. I just cancel them out. They're gone. It's like a 1. All right? So what's the answer to the first problem? What's 1 times x to the 4th? 1x to the 4th, right? Okay? Now I do the numbers first, and then I do the variables. So what's 4 times 2 to the 1st? 8, right? You got to do 2 to the 1st. You got to do exponent first, right? Well, 2 to the 1st is 2 times the 4 is 8. And then x to the what? 3rd. What's 2 squared 4 times 6, 24. X to the second. What's 2 cubed? 2 times 2 is 4 times 2, 8. 8 times 4, 32. X to the first. And then what's 2 times 2 times 2 times 2? 16 times 1 is 16. So here's my answer to this. X to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. 1, 2, 3, 4, 5 terms. Is that how many I'm supposed to have? Yes, remember, it's always one more term than you have for your degree there, your exponent, the degree of 4. It's really pretty easy. It takes a little time to set it up. Okay? You guys try one for me on your own. All right? Whoa. Where's the B? It's in there somewhere. There it is. Okay? So do this one to the third power using Pascal's triangle. So how many terms will you have when you're done? Since it's to the third power. 4, right? So remember, you're going to have 4 terms in our answer.
Because I think that right now. Very good. Super ultra. Very good. I did this to a kid in the hall. He heard that. You took the step back. I thought it had it in my head. If I had moved a little bit. World's longest equation. I thought I had it nailed. I got it. Left would have gotten in the face. So do you have a book? Perfect. Why did you throw it? Buddy had it down. Bag your head.
There's 4 terms, right?
What do you mean by I need to know?
Right now you're second. 0, 1, 2, 3.
So you have to make the triangle. I did. I didn't. I'm ready. It doesn't have to be that long. You don't need it that long. Yeah, I need it. You only need the amount of rows. The amount of rows after 1.
0.
Okay, so why is that?
Just right. No. That's just right. You see. Yeah, you put so 1K, 5, and then you do 3, and then K, and then -5. It's a lot easier to not think of it all as 1, 3, and
I do. All right, you guys about ready to go over it? You guys keep working on it. I'm just gonna start setting it up for me.
So, the other one would go up. I know. You pick up the balls. There's no way out of the
No, that, I don't think that would. Maybe your girlfriend or your daughter, like, I don't know.
Can you stop throwing it at the
Caleb, you're the one that started this.
It honestly went burn.
You're the one
And
that
I'm not
started
looking backwards because I totally heard it.
All right, eyes up here, please. Is that what yours looks like when you set it up? We good? So what do I do with those parentheses to the 0 power? Don't even worry about them, right? Because they just turn into 1s, so it's not changing anything. So we don't even worry about it. All right, so what's 1 times k to the third? All right. I always do this second parenthesis first because it's going to have an exponent. What's negative 5 to the first? Negative 5 times 3, negative 15, and then k squared. What's negative 5 times negative 5? Positive 25 times this 3 is 75, k to the first. So you can put to the first or you just leave it k. And then what's negative 5 times negative 5 times negative 5? Negative 125 times 1 is still negative 125, right? That makes sense? That might be easier than trying to remember that rule we went over yesterday.
Yeah, I can't remember that.
I think that's easier, personally. Do we need to do another example, or are we okay? Now remember, what's going to go in the first parenthesis? 6m, right? So you're going to have a 6 to the third, m to the third, right? And then times that, and go from there, right? Sydney, you got a question? Okay. So here's your assignment. Good job. Use Pascal's triangle for all of them. 41 and 44, the directions tell you to use Pascal's. 34 and 36 was like last night where you could use those special products. Yeah, just use Pascal's on every question.